In this episode, we'll continue working with the Learning Tasmota PCB, integrating it with an MQTT broker. You will learn the must-know features of MQTT for Tasmota in less than 15 minutes. From here, you can confidently set up and install your own MQTT broker, such as Mosquitto, knowing a bit more about how it works and how to use it. Let's get started. In episodes 1 and 2, we designed, built, and configured the Learning Tasmota PCB. Previously, we worked with Tasmota in more or less a non-connected manner, only managing the device from the web interface. In this episode, we will integrate it with an MQTT broker and learn the must-know Tasmota commands. We will use the open-source Mosquitto broker project. When I got started, I first installed and configured Mosquitto on my Raspberry Pi. It took me quite some time to get everything working. Since I had never worked on an MQTT broker before, I was not exactly sure what I was doing. It's sort of like learning to frost a cake, but having to learn how to bake a cake first. We will be using the figurative pre-baked cake to learn how to frost. This pre-baked cake is the test.mosquitto.org broker. Once you have learned and have some mastery of MQTT, it would make sense to bake your own cake by installing your own Mosquitto broker with a complete and secure configuration. To simplify the software installation, we will be using the MQTT Lens Chrome plugin application, which is a complete client ideal for initial learning. You will be working with MQTT in less than 2 minutes using this method. During our session, we will examine the data coming out of the Learning Tasmota PCB while also learning how to send MQTT commands for remote actuation of the buzzer and the LEDs. Special focus will be made on the study of MQTT topics and how they are used in Tasmota. And finally, we have a special surprise for you in the bonus section that builds on today's learnings. Let's start off with a quick explanation of what an MQTT broker actually does. In simple terms, it's a lightweight machine-to-machine protocol that makes the Internet of Things possible. It is based on a publish-subscribe model that transport messages between devices, middleware, and applications. The footprint of MQTT is very light and often uses JSON or JavaScript object notation to exchange more structured blocks of information. MQTT provides a layer of simplification for the Internet of Things and is the lingua franca of devices today. In its most simplistic form, there are two elements, a broker and a client. Clients publish things like telemetry and state information on a topic to the broker while also subscribing to topics on the broker so that they can actuate needed activity when requested. Here's an example. I may want to turn on the relay in a soft switch to turn on a light. To enable this, there would be two devices, a smartphone app similar to the MQTT Lens and the Sonoff Smart Switch running Tasmota. The Sonoff Smart Switch subscribes to a specific topic or rendezvous point for itself. On the other side, the smartphone app publishes a command to that same specific topic to turn on the light. The MQTT broker provides a helpful layer of indirection to IoT devices. As a result, they do not need to know a lot about each other. This greatly simplifies the programming logic on the devices and allows for a smaller footprint, making them easier to maintain over time. Today we will use two clients, the Learning Tasmota PCB and an MQTT app. I suggest using a simple to install app for the Chrome browser called MQTT Lens. It takes minutes to install and set up. Of course, there are many other MQTT clients on the Chrome, iOS, and Android app stores that could also be used. Let's start by installing MQTT Lens on our Chrome browser and then attaching it to the public MQTT broker. From Google, we will enter the search text simply MQTT Lens. The Google Chrome Web Store entry should show up in the first couple of responses in the search. Click on MQTT Lens and then on the Add to Chrome button in the upper right-hand corner. It should only take seconds to install. You will then see MQTT Lens in a list of all of the apps that you've installed on Chrome. Now click on the MQTT lens to start the app. Once it has started, you will need to add a connection to the broker. For the purposes of our initial learning, we will use the test.mosquitto.org broker without any security. This will quickly allow us to learn MQTT and how it works with Tasmota. We can build our own MQTT broker on our own home or business network later and add the proper recommended security. We only need to fill in two fields, the connection name and the host name, which is test.mosquitto.org. The other default values will work fine as is. Now go to the bottom right-hand side of the form and click Create Connection. If everything worked, you will see a green play icon in the connection profile. You're already connected to the broker. Congratulations. This is the equivalent of having a plain cake that just came out of the oven. Now we will learn how to frost the cake. With MQTT Lens configured and working, let's configure Tasmota running on the Learning Tasmota PCB to connect as a client to the very same broker. To do this, we will connect to the local LAN web address of the Learning Tasmota PCB that we previously configured. From the main menu, we will go to the Configuration option and then to the Configure MQTT option. Here we will add the name of the same MQTT broker host, which is test.mosquitto.org. That's it. Now save the configuration. The device will now reboot and connect to the test broker. To verify it worked, we will need to go to the console from the main menu. If you do not see any errors, it likely worked. If you do see errors, re-verify that the entry you made in the Configure MQTT option is correct. We've now successfully connected two clients to the test broker. Let's start learning how to frost a cake by focusing on how to publish and subscribe. To start, let's look at how Tasmota publishes information to the broker. There are three primary rendezvous points or MQT topic formats that are used. Telemetry topics are used to communicate sensor data. This is sent out at a given interval and the default is 5 minutes. Status topics are used to communicate changes in any state as they occur. For example, the relay was just turned off. The relay was just turned on. Finally, command topics are used to actuate a Tasmota device to perform some function. For example, turning on a relay or turning off a relay. Just after the Learning Tasmota PCB device is booted, you will notice several status and telemetry messages being sent from the console interface. Let's watch these from our MQTT Lens client. To do this, we need to subscribe to the necessary device topics published by Tasmota. In looking at the console, we can see, for example, a sensor update was published to tele for telemetry / Tasmota, I won't name the device name, / sensor. Let's copy that line and paste it into the MQTT Lens subscribe field. This is a very specific topic for a sensor message on this device. Let's also subscribe to a status topic so that we can see some specific messages from this device when they occur. We will copy and paste this topic from the Tasmota console. After entering these topics into MQTT Lens, you may see messages from the Learning Tasmota PCB immediately arrive. By pressing the reset button on the Wemos D1 Mini on the Learning Tasmota PCB, we will see some of the messages sent out just after the device boots. Let's focus on a few of the critical topics, starting with the sensory telemetry data. The latest sensor data, including the light and temperature, shows up in the telemetry sensor topic. Again, in this case, it's tele / device name / sensor. It is sent out every 5 minutes by default. You will notice it is a JSON formatted string as follows. Let's change this to be sent out every 30 seconds as opposed to every 5 minutes with the command tele:30. We will now see these arrive on our MQTT client more often. Now let's push the momentary push button, which is connected to switch 1. We should see two MQTT messages on the status result topic. Let's look at these more closely. One message was sent for the button being pushed down and another when it was released. Because we created a Tasmota rule, that reacts to a switch 1 event by turning the LED on and off, we will also see these state changes for the same topic. Finally, let's look at the command topic. We will focus on actuating a few components on our Learning Tasmota PCB. From the MQTT Lens client, we will publish a few commands intended for the Tasmota device. To turn on LED 3, we will publish a message to command device name LED power 3 with a payload of simply on. To sound the buzzer device 5 times, we will publish a message to command/device name/buzzer with a payload of 5-1. Finally, we can change the intensity of the fourth LED, which has a pulse width modulation or PWM configuration, by publishing a topic command/device name/dimmer with a payload of 50 or 50%. Let's publish these commands from MQTT Lens to the broker and see what happens. First, we will do the LED power 3 command. Then let's sound the buzzer 5 times. Finally, let's set the fourth LED to a 50% duty cycle for PWM. It should be noted that we can publish these same commands from the Learning Tasmota PCB on the console interface. For example, we can run the following 4 commands, which will send out MQTT published messages directly to the broker. These, of course, will then come right back to the Learning Tasmota PCB and then actuate. Or we can make up our own topics, such as command/marktroyer.tech/message, and send a plain test message. This is a rule execution in episode 4. Let's enter these commands directly in the Tasmota console. First, we will do the LED power 3 command. Then the buzzer command with 2 beeps. Now let's set the LED 4 brightness to 75%. And finally, let's send a message to marktroyer.tech. This is a rule execution in episode 4. We did this through a separate MQTT client, but we also published commands directly to the broker from a Tasmota device. Now it's time for the bonus section. Let's pull all of this together by creating a super cool Tasmota rule. In this case, we will publish a message to the marktroyer.tech topic when the switch 1 button is pressed. Effectively, we will wait for the switch 1 action equals on event and then submit an MQTT publish. So copy paste, and there we go. Pressing the button results in a Tasmota rule execution which publishes a command. Let's wrap up and summarize. Today we learned how to frost a cake with a pre-baked cake. We configured an MQTT client and the Learning Tasmota PCB to work with the tests.mosquitto.org broker. We then watched the data originating from the Learning Tasmota PCB arrive on the MQTT client. We learned the basics about Tasmota MQTT topic nomenclatures, namely the differences between a telemetry, status, and command topic. With this, we received temperature and light sensor data from Tasmota and learned how to actuate components such as the LEDs and the buzzer. Finally, we learned to publish MQTT commands from Tasmota and use this to create a rule which sends a greeting to the marktroyer.tech topic when the button on the Learning Tasmota PCB is pressed. So it's time to wrap up. Were you able to follow along with the steps in this episode? And did everything work as you had expected? In a future episode, we will build on this series by creating a nice functional user interface for the Learning Tasmota PCB using Node-RED. If you found this video interesting and useful, please like it. I'm trying to get this channel off the ground and would appreciate your feedback on the topics I've covered so far. For the next 10 episodes, I will continue to dive deeper into all things IoT. There will be more focus on middleware elements such as Node-RED and the Things Network and other complementary platforms. Your feedback to direct me in the areas of your interest would be appreciated. That's all for this episode. Thank you for joining. This is Mark at marktroyer.tech signing off.